Okay, number 3. Venus and Serena measured a tennis court and found that it was 42 feet longer than it was wide and had a perimeter of 228 feet. So tennis courts are rectangular. So we know that the is 42 feet longer than it is wide. We don't know the width, we'll say that, but 42 feet longer than that is that. And we know that the perimeter was 228. Well, we're going to add up 4 sides. So we're going to say x plus 42 plus x, those are the 2 sides. We'll multiply that by 2 so that we can count for the other 2 sides, and that's going to be 228. So we'll distribute this and say 2x plus 84 plus 2x equals 228. 2 plus 2x is 4x. We'll move the 84 over by subtracting it. And we'll have 4x is equal to, I'm just going to grab a calculator here. 228 minus 84 is 144. And then we'll divide by 4. And we'll get x is equal to 36. So that tells us the width. To find the length, we need x plus 42. 36 plus 42 is 78. So the dimensions are 36 feet by 78 feet. That's it. Okay, number 11 says that Andrew McGinnis works at Arby's. During one particular day, he sold 15 of these junior roast beefs and 10 big Montana sandwiches for this amount here. And another day, he sold 30 junior roast beefs and 5 big Montanas for that much. How much did each type of sandwich cost? So let's start there. Equals the cost of a junior roast beef. And I'm gonna call that J, and equals the cost of a big Montana. I'll call that B. Now, let's look at the first sentence. The first sentence says that 15 junior roast beefs and 10 big Montanas cost that much right there. So 15 of the junior roast beefs plus 10 of the big Montanas costs $75.25. Now the second sentence says 30 junior roast beefs plus 5 big Montanas is $84.65. Now, we can get rid of these by bringing them to 30, or these by bringing them to 10. So I'm going to get rid of these by bringing them to 10. So I'm going to multiply this, not by 2, but by -2. And that's going to give me negative 60J minus 10B is equal to, and I'll just do this on a calculator, 84.65 times 2. It's going to be a negative 169.30. I'll leave this one alone without touching it. These are capital B's. So I'll add these together. 15 and negative 60 gives me a negative 45J. The B's go away. And these add up to negative 94.05. So I'll divide each side by negative 45. And we're going to get J is equal to a positive 2.09. So that's what a junior roast beef costs. Now to figure out the other one, we'll plug it into either one of the originals, like say this one right here. So 15 times J plus 10B equals 75.25. and J is 2.09. We just solved for that. So 15 times 2.09 is 3135. Now bring the 3125 over by subtracting it. Oh, that's a 3135. And we'll get 10B is equal to 4390. So now we'll divide by 10, and we'll get B is equal to 4.39. So I'll write it up here. A junior roast beef costs $209, and a big Montana costs $439. Let me write that a little better. And that's it. Okay, we have 60 ounces of solution. If it's a 10% concentration, then we have 60 times 10%, which has a decimal is 0.10 or 0.1, is equal to 6. So there's 6 ounces of pure solution. Acid, I guess it is. Okay, that was part A. Part B is 60 times 0.25, which is 15. Part C is 60 times 0.4. Let's see, that's 24. So it's 24 ounces of pure acid. And part D is 60 times 0.5, that's 50%, which is 30. So we have 30 ounces of pure acid. That's it. Okay, for these mixture problems, you're going to write a chart, and the chart is going to be the number of whatever type of unit that you're using. In this case, it's gallons, times the percent purity is equal to the number of pure whatever type of unit. So this is gallons. Make a chart. Put enough for 3 lines in the chart. I'll put a double line down here, reminding myself that the bottom is the mixture. Put a line under the multiplication, a line under the equals. On the left, we're mixing together a 25%, a 35%, and our mixture is a 32%. Make sure that this number falls between these two numbers. That's the only possibility there. So this will be 0.25, this will be 0.35, and this will be 0.32. All right. We don't know the number of this, but we do know that there's a 20 gallons of pure. So this plus this has got to be equal to this. That means this has got to be the total minus that. Now it doesn't matter what x is. When I add it up, these go away and we get 20. So whenever you don't know what 2 items are, but you do know what they add up to, choose a variable for one of them and the total minus that variable for the other, and they'll always add up to that total. Okay, we'll multiply to get this, so that's 0.25x. We'll multiply these, we'll get 0.35 times 20 minus x, and we'll multiply these two. So the equation is this plus this is equal to this. So we have 0.25x plus, I'll distribute this, and let's see, that's 7 minus 0.35x is equal to 6.4. So 0.25 minus 0.35 is negative 0.10, and 0.64 minus 0.7 is a negative 0.0. X is 0.6, not 0.06. So this, if we divide everything by negative 0.1, we'll get x is equal to 6. And that tells us that there's 25 or 6 gallons of the 25% purity solution. And this tells us that there's 20 minus 6, which is 14 gallons of the 35%. So let's write it out here. 6 gallons, I'll just leave it like that, of 25% acid and 14 gallons of 35% acid. Okay, here we have 12 liters of a 12% solution must be mixed with a 20% solution to get a 14% solution. So let's start with the number of whatever type of unit we're using. This is liters times the percent purity is equal to the number of pure whatever type of unit we're using, liters. I'm going to make a chart big enough for 3 things. I'll put a double line on the bottom to remind myself that the bottom is the mixture. A line under the multiplication, a line under the equals. So we have a 12%, a 20%, and a 14% mixture. So let's fill out this chart, this column. Okay, now it says that there's 12 liters. So this is 12. There's no ambiguity there. There's just 12. And we don't know the number of liters here, so we'll do that. And we're adding these together to get this. So this bottom one is just a sum of these, which is x plus 12. Now we're multiplying these to get this. So this is going to be 12 times 0.12. This will be 0.2x, and this will be 0.14 x plus 12. The equation is that this plus this is equal to this. So I have 12 times 0.12 plus 0.2x is equal to 0.14 times x plus 12. Okay, so I'm going to get a calculator. 12 times 0.12 is 1.44. I'll distribute this and get 0.14x plus, that's 1.68. So now I'm going to move this over to the left by subtracting it. And I'll move this to the right by subtracting it. And we're going to get, this will be 0.06x, and 1.68 minus 1.44 is 0.24. And we'll divide by 0.06. And we're going to get x is equal to 4. Now let's bring this up here. We just found that that's actually all they're asking for how many liters of the 20%? 4 liters. So 4 liters of 20% acid solution. And that's it. Okay, the last problem. How many liters of pure dye must be added to 4 gallons of this? Okay, so I'm going to start off with the number of whatever type of unit we're using. This is gallons, times the percent purity is equal to the number of pure gallons. I'll put a chart big enough for 3 things. Put a double line there to remind myself that the bottom is the mixture, a line under the multiplication, and a line under the equals. Alright, we have a 25% dye, we have a pure dye, and our mixture is a 40% dye. So pure dye is 100%, which is as a decimal 1, This is 0.25, and this is 0.4. We have 4 gallons of the 25% dye. The pure dye we don't know, so that's just going to be X. And this is the sum of those two, so this is X plus 4. This is 0.25, times 4. This is 1X, and this is 0.4 times X plus 4. The equation is this plus this is equal to this. So 0.25 times 4 plus 1X is equal to 0.4 times X plus 4. So this is 1. We'll distribute this and get 0.4x plus 1.6. Now I'm going to move this to the left by subtracting it. And I'll move this to the right by subtracting it. And we're going to get 0.6x is equal to 0.6. We'll divide by 0.6, and we'll get x is equal to 1. So 1 liter of pure acid. And that's it.